Hello again. Thanks so much for coming out tonight. My name is Seth McLaughlin. I'm the organizer of the meetup. Tonight we're going to be hearing from Eric Rowell, who works here at LinkedIn as a senior developer, and he's the creator of Kinetic.js, a very popular JavaScript framework for dealing with Canvas-based graphics. And he's going to be talking about not only his framework, but also other frameworks and other options for creating graphics on the web, and to give you an idea of what's out there and what are the pros and cons of some different approaches. So without further ado, Eric.
How are you guys doing? Welcome to LinkedIn, by the way. Okay, so as Seth mentioned, I'm actually going to try to be pretty unbiased, even though I'm the creator of Kinetic.js. I'm going to go over a lot of different technologies that are available for graphics on the web. And let's see. And also talk about some of the cool libraries out there, like Kinetic.js, Easel.js, Fabric, 3.js. There's actually a lot of different options. And I'm going to kind of go through each one and make recommendations about which ones are best for which situations. So today's agenda, I'll quickly go over a history of graphics on the web to kind of give you guys some context about how graphics on the web began, how new technologies came into play, and where we are today. I'll talk about pros and cons of different technologies, and I'll go over the some modern web graphics libraries today in 2013. So that'll be part one. And part two, since I created Kinetic.js, it seems appropriate to kind of talk about that one a little bit more than the other ones. So I'll give a Kinetic.js intro plus some demos. I'll try to be brave and do a live coding example and see how that goes. And I'll finish up with a Kinetic.js overview and questions. So I actually have a lot of information to cover, so I think we'll do questions at the very end at about 8. So I'll let you guys know when that time comes. Okay, so who am I? My name's Eric Rowell, as Seth mentioned. I'm a senior web developer at LinkedIn. I've been here for 5 months. I previously worked at Yahoo, and as I mentioned, I'm the creator of Kinetic.js. I'm also the founder of HTML5canvastutorials.com, which I believe is the largest Canvas tutorials website that's available. And I'm also the author of HTML5 Canvas Cookbook, which is published by Pact. That was released or published about 2 years ago, so it was one of the first ones that came out. So enough about me. I'd like to know a little bit about you guys, just to kind of have some context about the audience. So how many of you are active JavaScript developers? Okay, so a good amount. HTML5 Canvas experience? Okay, a little bit less. Flash? Silverlight? Okay. SVG? Okay. HTML5 Canvas libraries in general? So even less, okay, 1 or 2. Kinetic.js? No one, cool. Well, at the end of today, I'm sure all of you guys will be pretty stoked about it. So to get started, I wanted to give context on the history of graphics real quick. It sounds boring, but it's actually only like 5 or 10 minutes. And also a disclaimer, I'm not an historian. I just want to kind of give you guys some context about how graphics came onto the web. So for that, I'm actually going to jump out into a quick, cool presentation. And we'll start with this one. Okay, so you have a cool little path. That's like the little history of graphics. Okay, Macromedia Flash in 1996. It was originally called Future Splash. Not many people know that until it was acquired by Macromedia in 1996. They shortened the name by combining Future and Splash. They created Flash. Macromedia was later acquired by Adobe in 2005. And as we all know, Adobe Flash is a browser plugin. Browser support, all major browsers, including IE 6, 7, and 8, which is probably one of its biggest selling points. VML was introduced in 1998. It stands for Vector Markup Language. It's an XML-based format, and it was actually developed by Microsoft. It was submitted to the W3C in 1998 by a handful of folks, including Microsoft. And browser support, unfortunately, is just IE5 through IE9. Microsoft really believed that VML was going to be the future, so they really stuck to it for a while. They eventually gave up and supported SVG later for IE10. Let's see. So SVG came out 1 year later, and that stands for Scalable Vector Graphics, which is also an XML-based format, XML-based file format. It was created by the W3C shortly after VML was submitted. So basically around this time, a lot of different proposals were being submitted to W3C, and they eventually decided to draw on the strength of each of the proposals, and they came up with SVG. It's actually very, very similar to VML, and it works in all major browsers except for IE less than 9. Because again, Microsoft was pretty stubborn and they refused to support SVG until IE9. Almost finished. So Canvas 2004. So it was created by Apple for Mac OS X, dashboard widgets, and WebKit. It was later adopted by Gecko in 2005, Opera in 2006. It's raster-based, so unlike VML and SVG, it's a bitmap. It was standardized by WhatWG, and they eventually released the first working draft in 2008 as HTML5 Canvas. And browsers began implementing it despite the fact that it was incomplete. And actually, the spec went back into a working draft in 2012, so the spec is actually still evolving today. It's not complete. HTML5 Canvas currently supports 2 different contexts, a 2D context and a 3D context. The APIs for both of those are completely different, but they allow you to create 2D graphics and 3D graphics. And browser support, all major browsers except for IE less than 9. Okay, so where are we today? So modern web graphics 2013. So basically, if you're going to create a graphically intense application today, you have a few primary options, which are HTML5 Canvas. You can pick 2D or WebGL. You can go with Adobe Flash, or you can go with the combo of SVG and VML. So let me jump back. Okay, so back to the boring slides. Hopefully I didn't get too dizzy from all the navigations. Okay, thanks, Eric. Now I'm even more confused. How do I know which technology to roll with? Regular HTML, Flash, SVG, HTML5 Canvas? Ugh. So chill, it'll be okay. We'll figure this out. We have a lot of different options. So that's kind of the quick history. And we also know what kind of options we have. So I'm actually going to try to go through some of the pros and cons for HTML, Flash, SVG, and Canvas, which is actually a big undertaking because there's tons of pros and cons for each one, but I tried to get the biggest ones. So we'll start with regular HTML. As you guys probably know, it's technically possible to create graphical applications with regular HTML, like using DOM elements. So the pros, it's supported by all browsers. You have the availability of form controls, and it's semantic, which means it's accessible. The cons, if you use regular HTML, it renders very slowly when there's lots of objects on the screen. So once you get to like hundreds or thousands, your browser will slow down. If you get more, it can actually crash. It clutters up the HTML document. It's difficult or impossible to create complex shapes. So if you're creating a graphical application with HTML, you're pretty much limited to rectangles, boxes, rounded corners, and images. So you're kind of constrained. Unless, of course, if you're using modern browsers, you can use like CSS3 transforms, transitions, and animations to kind of give you some cool, some more functionality. Okay, Flash. So the pros, it's supported in all desktop browsers, even IE6, 7, and 8. And it can access hardware devices such as cameras and microphones. So that used to be its most important attribute, but now HTML5 can also do this with the get user media method. So now JavaScript can actually has access to your hardware devices such as cameras and microphones. So Cons, no JavaScript. Not that JavaScript is the best language in the world, although I think it is. If you have an application mixed with JavaScript and ActionScript, you have two code bases, and it's a little bit harder to have code reuse. It can't run on mobile devices because Apple didn't want it, and Android eventually dropped support for it. And it causes Macs to crash. Just kind of kidding. Okay, SVG. Pros. So it performs fairly well for large objects if you have large viewports. It's easy to bind event listeners to nodes or modify properties. So because SVG elements are actually DOM elements, you can interact them with regular JavaScript or jQuery. And you can export graphics from editors like Adobe Illustrator to an SVG format. That's pretty powerful. If you want to create some vector graphics using an image creator like Adobe Illustrator, you can create the graphics and then export it to SVG and plop that into your HTML page. Bullet number 2. Oh, easy to bind event listeners. So let's say you have like a circle on the page and you want to bind a click listener. So it's really easy to attach click listeners, mouse overs, mouse outs to that element. Because it's a DOM element, it works the same as like divs or anchor tags or paragraph tags. Cons, it renders very slowly when there's lots of objects on the screen. So it kind of has a similar cons as SVG. Clutters up the HTML document, and it's not supported in IE 6, 7, or 8. So in that respect, it has kind of the similar fallbacks as regular HTML. Okay, so cooler stuff. So more modern things, HTML5 Canvas context, 2D context. So you can quickly see there's actually not very many pros and lots of cons, which is a problem. So let's go through those real quick. So the pros, it runs extremely fast. That's a huge pro. That's its biggest selling point. It can run on mobile devices, and you can do pixel manipulation with 2D context, with the Canvas 2D context. So you can take an image and modify pixels, so you can completely alter an image in the browser, which is pretty cool. Lots of cons. It's not supported in IE 6, 7, or 8. Because it's a bitmap, once stuff is drawn onto the canvas, you can't access it again. No support for binding event handlers. It can run slowly if you have very large viewports and you're constantly redrawing the entire canvas. And it's also not very easy to redraw a single element. So because Canvas is a bitmap, if you want to update like a small circle on one section of the canvas, you have to redraw the entire canvas element. Or you have to use clipping regions and redraw like a small section of the canvas. So filters, there's a lot of use cases where people want to take an image and blur it, or make it grayscaled or invert colors, or just kind of do fancy stuff with the image. So like eventually, I think some people have been making kind of like Adobe Photoshop type functionalities in the browser, and those types of applications would need to be able to access the pixels in an image. There's actually a lot of cool things you can do with that. Okay, so yeah, as I mentioned, not very many pros, but the pros are very, very strong pros and lots of cons to overcome. So this is an interesting graphic I'm going to show you guys. I put this together last night. It's called Eric's Web Graphics Libraries Triangle. So based on all those different technologies, a lot of people have created libraries to try and overcome the pros of certain technologies so that they can they tried to overcome the cons so that they could surface some of the pros of different technologies. And so today, as I mentioned, the three main technologies you can choose from are SVG, 2D Canvas, and WebGL Canvas. You can also choose Flash, obviously, but there's not really any libraries that wrap around all of Flash that I'm aware of. So typically, if you're working with a library that wraps around the technology, it's going to be based on SVG or Canvas. So if you were to choose to go with the SVG route, there's two major players, D3 and Raphael. I'm going to talk more about these in the next slide. Also, maybe to be a little bit more clear about what this triangle means. So if you look, say the SVG circle, so the closer a library is to that circle, the more of a dependency it has. So for example, D3 and Raphael are completely dependent on SVG, and actually Raphael is also dependent on VML. WebGL, which is 3D, 3JS is the main player in that space. In fact, I think they have pretty much a monopoly in that space. So if you wanted to create 3D graphics, you pretty much have to go with 3.js. Processing.js is kind of a mixture of WebGL and 2D Canvas. So if you're a fan of the processing programming language, it's basically a port to JavaScript that was created by John Resig. And so you basically use the processing language, you compile it into JavaScript, and it will run in the 2D Canvas or the WebGL Canvas, depending on the situation. So it's a pretty cool little project. You'll see this little cluster over here. So there's 4 big libraries in the space of just pure 2D Canvas. So as I mentioned, the 2D Canvas, the biggest pro is that it's fast, but it has lots of cons. It's hard to attach event handlers to elements. It's not object-oriented. And it's really hard to mess with situations where you want to update a single element and not update the entire canvas. So all of these libraries down here were created to solve that problem. Each of them solve it in slightly different ways. They're all somewhat similar. Each of them have some slight different pros and cons, which I'll go over. And so those 4 libraries are Fabric.js, Kinetic.js, Paper.js, and Easel.js. And also, just to be clear, so this part of the presentation, I'm kind of trying to give you guys a sense of what's out there. I obviously can't go deep into all of these libraries in 1 hour, so I just kind of want to give you guys, tip of the iceberg kind of information. And the positioning of these libraries actually has meaning. Easel.js, for example, is mostly geared towards the 2D canvas, although they do have some SVG and even some 3D components. So Easel.js is probably somewhat the most balanced of all the libraries here. Paper.js is pretty much predominantly based on 2D canvas. Kinetic.js is mostly based on 2D canvas. This is my library. It's a little bit closer to SVG because it has the ability to import SVG paths and then convert them to Kinetic.js objects. Fabric.js is somewhat similar to Kinetic.js. I put it a little bit closer to SVG because Fabric.js is able to import SVG graphics and also export. So it has a little bit more of an SVG flair to it. Let's see, we are at 19 minutes, okay. This is a heavy slide, I'm sorry. I just wanted to quickly give you some recommendations for different situations, maybe which library you might want to choose. This is the biggest slide of the presentation, so sorry for that in advance. So if you want to create simple charts and graphs, and you need them to run in all browsers, including IE less than 9, I would recommend going with Raphael.js because it has 1 API and 2 renderers. It has an SVG and a VML renderer. And as I mentioned, Internet Explorer less than 9 only supports VML. So you need those 2 different renderers to handle all the browsers. If you want to create simple data visualizations that bind DOM elements to data, you could go with D3. The problem with D3 is it doesn't have a VML component to it. So a lot of people actually combine Raphael.js and D3. They'll use Raphael.js to create the graphics, and they'll use D3 to bind data to those DOM elements. If you want to create something really fancy, some intense data visualizations with limited interactivity, when I say limited interactivity, I mean like limited mouse or touch interactivity, and you have experience with processing, I'd recommend checking out Processing.js. You can create some really cool visualizations, and if you don't care too much about being able to interact with the pieces on the canvas, that would be a good route to go. If you want to create intense, high-performance graphics applications, charts, 2D games, and you don't care about older browsers, I would recommend going with Kinetic.js or Easel.js. So I think of all the libraries out there, Easel.js is probably the most similar to Kinetic.js. So after this presentation, when you go home and if you want to do your own research, I highly recommend looking into both of those as well. And so the image manipulation. If you want to do complex image manipulations, I believe Paper.js has the best support for that. They have a lot of cool, their API is pretty interesting, and they have a lot of different options for accessing pixel data and manipulating pixel data. Even though like Kinetic.js and Easel.js has built-in filtering, with both of those libraries, you can apply blurs and grayscale and invert colors, those sorts of things. Paper.js has a little bit more functionality. And the easiest one, if you want to make anything 3D, Three.js is pretty much your only option. It has monopoly in the 3D space. Yep.
I have a question. You mentioned that with Canvas, you can't really bind like event listers.
Right.
So if you, I'm imagining, for instance, charts, you wanted to make it interactive. I guess that's the disconnect that I have is if you want like games and charts where it's interactive, why would you use Canvas and not something like an SVG?
You would use a library. So, oh, sorry. Yeah. So to repeat the question was, what's the point of using Canvas if you can't bind event listeners? The answer is, so as I mentioned, it renders very, very fast. If you're going to create a game with pure Canvas, you're going to have to implement your own logic to handle binding event listeners, which is actually really, really hard. The reason Kinetic.js was created in the first place is because I dealt with that problem when I was creating HTML5 canvastutorials.com. It's exceedingly difficult to bind event listeners to different elements on the canvas in a really high performant way. So that was actually the basis for creating Kinetic.js in the first place. And if we go back, so these other libraries down here, most of them now support binding event listeners as well. So that's really the advantage. If you're going to create a 2D game, I'll definitely recommend using a library, or else you're going to write hundreds or thousands of lines of code to handle it yourself. It's not an easy problem to solve. Okay, so that's part one. If anyone has any questions, do you want to, I guess, sure.
For the Kinex and the ESO, they work on mobile web.
Which ones?
Those two, Kinex.js and
Kinetic.js and Easel.js both work on mobile. I'll go over Kinetic.js more in depth at the end. I believe Easel.js does work on mobile. I don't know if it works as well as Kinetic.js does in terms of events, but they do both run on mobile devices. Kinetic.js was also designed to work on mobile. It treats mobile as a first-class citizen, so it works pretty well. So I believe the question was, what did I take into account to make sure that Kinetic.js runs well in a mobile device? Just trying to keep things as lightweight as possible and keeping things rendering as fast as possible. There's nothing specific that needed to be done to make Kinetic.js run well on a mobile device. It actually runs pretty well by default. There's a lot of stuff that has to be handled, like the pixel device ratio. Since mobile devices tend to have a pixel device ratio of something like 2, you have to, Kinetic.js does a lot of stuff under the covers to take care of that for you. But as far as performance, it runs pretty fast, and there's not really much that was done special to make it run fast on mobile compared to desktops. But we'll go more into Kinetic.js here pretty soon. Any other questions so far? Yep. So I would actually recommend using Canvas still. There's plenty of good demos for Kinetic.js and Easel.js that show maps. In fact, I'm going to show you guys a really cool demo of a map that was built with Kinetic.js here in a minute. And the question was, sorry, I forgot to repeat the question. The question was, which technology is best for creating maps? And so Canvas, I think today, is a good option for that. Any other questions so far? Okay. Okay, so Kinetic.js. So as I mentioned, I created Kinetic.js almost 2 years ago. It's been in GitHub about a year ago. So Kinetic.js is a complete enterprise class HTML5 Canvas framework, which makes it significantly easier to create graphically intense applications like online games or interactive data visualizations. It's kind of a mouthful. Some high-level facts about Kinetic.js. It currently has over 1,400 GitHub followers, so it's an open source project. It sees over 130,000 unique page views on kineticjs.com. It sees over 200,000 unique page views per month on HTML5 canvastutorials.com. So since I own that property, I decided to go ahead and leverage it, eat my own dog food and host all of the tutorials there, which has worked out pretty well for me. If you search for some of these libraries on Stack Overflow, you'll find that Kinetic.js is actually the most tagged library topic on Stack Overflow by a landslide. So if you search for easel, paper, fabric, kinetic, you'll see a lot of heavy discussion around Kinetic.js. There was also a Kinetic.js starter book, which was recently published by Pact Publishing. It currently has 2 sponsors, Instadeal, which is an online poker game destination, and also Slotstell, which is a Facebook application. So if you guys get time later on, those are my sponsors. You might check them out. So Instadeal and Slotstell. And it's also a drop-down option in JS Fiddle. So I've made it big. Score. Okay. So before we go any further, I want to show you guys what this Kinetic.js thing can do. I have 5 or 6 demos. I'll try to get through these pretty quick. Let's see. So this is Slotstell. This is one of my sponsors. It's an online game. So it's kind of like Mario Party. It's like rolling a dice. You can walk down this path. You can win things. There's little mini games. It's kind of like an RPG sort of thing. So let's see what it looks like. Let's give it a spin. Pretty smooth animations, right? Does some walking. Awesome, 150. I've played this game like once or twice, so I really have no idea what's going to happen. Like something really terrible could happen. I have no idea. I think you can also do there's like an auto spin. So they have some cool transitions down here. Let's do 5 auto spins. So that's pretty neat. I'm really glad that Facebook is allowing HTML5 apps now, which is pretty cool. So Kinetic.js is a great framework to use for that. Okay, I'm sure you're bored of this by now. Let's see what else we have. Tetris. I've always wanted to do this, play Tetris during a presentation. So let's see. Okay, I'm going to play for 2 seconds. I can't believe I just did that. I really can't. Yeah, it's pretty smooth, right? I was imagining that when I played this in front of you guys, I would be awesome and do great, but you get the idea. It looks pretty nice, right? Let's pause this. Okay, and what else do we have? So Kano Games, they have an application where you can build an avatar. In particular, it's a robot. I love robots. If you ever were to see my my cubicle at LinkedIn, there's robots everywhere. Let's see. So it's a little robot creator. You can choose let's see, pick a head. So drag and drop functionality is pretty straightforward. Let's rotate some stuff. You kind of get the idea, right? So pretty smooth. Let's see, I've got a few more. This one's cool. So Green Sock. There weren't a lot of Flash developers here, but actually GreenSock created probably the most famous tweening library for ActionScript. And they created some cool transitions for Kinetic.js. They also used some Pac-Man and Pac-Man sprites, which are pretty neat. That's pretty cool. So with Kinetic.js, you can animate or transition things along a path. It's a pretty smooth animation. They actually sent me a demo with like 2,000 of these, and it rendered really smoothly. So it's pretty fast. So again, Canvas, that's the big benefit, right? It's really, really fast. You can actually, I have a lab on my tutorials website that plots 20,000 nodes in no time, and the interactivity is actually instantaneously fast. I had someone send me an email a few days ago saying that they wrote an app that plotted 1 million nodes, and they said it could render in about a second, and the event detection was still instantaneous. So 1 million nodes in the client is pretty awesome. He might have had an awesome computer, but that's what he told me. Let's see, a couple more. Okay, so here's the map I was mentioning. I picked this one because this is my favorite game of all time, Risk. So they have made a nice, pretty little Risk map. So if you're creating like any kind of maps, you can create these shapes. Either you can use, there's several ways you can do this in Kinetic.js. You can use polygons, you can use splines and map the points, or you can even create, you can export SVG paths into Kinetic.js to generate these kinds of shapes for the map. So I thought they did a pretty good job. It's a pretty slick looking Risk map. And one more. This one's probably less cool, but it's still cool to show. I wanted to show some kind of a charting thing. Pie charts, of course. So this guy made a deal to where you can hover over these different places, and it'll map a line to the corresponding wedge. And as the wedge is selected, the wedge will actually transition in and out, which is pretty neat. Sure, a question? So the question was, for HTML5 Canvas, the 2D context, do I see big performance differences between browsers? Currently, I haven't seen anything major. I hate to say it. I hate to say the word surprisingly, but even IE9 seems to handle the 2D context very well. I haven't had any tickets filed against like slowness for different browsers, so I think all the browsers have done a pretty good job so far of keeping the performance up. Any other questions so far? Sure.
So I'm guessing importing a physics engine.
Yes, very easy. I've seen several people do it. So in Kinetic.js, everything is actually an object. So you can use Box2D to connect with those objects and add the physics to those. You absolutely can. Okay. Let's go back to the slides. So that was a few demos.
What was the data in the pie graph?
It was like Facebook, let me see. Facebook users by country, I think. I don't even know if this data is accurate. He could have just made up stuff. I was just kind of going for the visual. Yeah, he did a good job. Actually, before I put this up, I looked at his code, and he could have made a lot of optimizations to improve performance. But even as is, it runs pretty well. Okay. How am I doing on time? It says 19. Is that counting down or up? Okay. So, not bad, right? Pretty cool stuff. Okay, so remember that giant mouthful of a sentence I had about the enterprise class? That actually means something. It's not just some jargon I threw into a slide. This is what makes Kinetic.js special or different. So from the beginning, it was built with a complete event model, including desktop and mobile events, event bubbling, cancellation, delegation, and custom events. So it's very much like jQuery or any other library. So you can hook into nodes inside of a node tree. You can bind listeners to individual nodes. You can bind listeners to parent nodes and listen for event objects to bubble up. You can capture it at that point, determine the target node, and do event delegation that way. It has special events that can be subscribed to, such as add or change and draw events, which the next slide I'll talk about why that's really important. It even has selector support. So if you're used to using jQuery or YUI and selecting elements inside of a node tree, this has some of that functionality. So for example, this line of code here, this basically means give me all of the elements with an ID of foo inside of the layer container, and then iterate on each of those items in the collection with the each method. So it's very similar to jQuery syntax if you have jQuery experience. This line of code basically means give me all of the rectangles inside of the group container. Which, by the way, how many of you guys have jQuery experience? So a lot. Great. Awesome. Oh, one note. So it's probably one of the biggest differences between EASL.js and Kinetic.js. EASL.js was heavily inspired by ActionScript. So if you're a Flash developer, the EASL.js API would feel really comfortable to you. If you're a jQuery developer, Kinetic.js would feel a lot more comfortable because a lot of the methods were inspired by jQuery methods. So in other words, so what does all that mean? So Kinetic.js is designed for large projects with many developers. So because you can hook into any kind of event changes, you can hook into draw events, you can select items from the node tree. Because you can do all that stuff, it's really easy to hook into other people's code without modifying it. So if you have a small team, say like 3 or 4 developers, and each developer is creating different components using Kinetic.js, it's really easy for each of those components to hook into each other by listening for events or using selectors. To my knowledge, none of the libraries today can do that. And of course, it's still great for small projects. If you want to create a small personal project, it'll work just as good. So guiding principles. So to kind of let you guys know like where my head has been when I'm creating this, speed is absolutely the most important thing for me. In fact, I've made it a point to include at least one big performance improvement with each release. So technically, Kinetic.js gets faster and faster with each release. I refuse to let it plateau or get slower. So speed is critical for me. It has gotten a lot faster. Even the next release, version 4.4.4, I have a change in there that takes care of transformation matrix caching, which basically I have a mechanism that caches transformation matrices, which actually improves the rendering performance by about 16 to 17%. It's a pretty big gain. And once that's released, I'll look into some more things to see if I can speed things up even more. So yeah, speed. So scale kind of goes along with speed. I want to be able to have applications with 20,000, 100,000, a million nodes in the client. Flexibility. Kinetic.js is extremely flexible. Every single thing you create, you can mix and match different config options and it just works. A familiar API. So if you have HTML, CSS, JS, or jQuery backgrounds, it should feel pretty familiar to you. And extensibility. It's very easy to extend and subclass classes in Kinetic.js. So if you want to create your own custom shapes, or if you want to create a different kind of layer or group, it's really easy to do that. Okay, so you're right. Kinetic.js does seem pretty neat. So what does the API look like? So this is the part where I'm going to try to be brave and do the live coding. We'll do this in about 10 minutes. So the best way really to show the API is to kind of code it as we go. So I'll do a really simple example. Okay. So one special thing about Kinetic.js, Kinetic.js is the only library that requires a non-canvas container. So usually you can use like a div. The reason for this is that Kinetic.js actually can manage multiple canvases for you. So that's a huge advantage because it allows you to define, you can define multiple layers in your application. Each layer has its own canvas element, which allows you to group things that are commonly redrawn together so that you can draw pieces of the canvas without having to redraw other pieces. So oh, go ahead. So what's the question again? Can you? Yep, absolutely. So the question was, can you connect layers? And you can. There's several ways. When you say connect, you mean like through events? So so one thing you could do, you could bind an event listener to the stage level. So layers are nested inside of the stage, and you could listen for events that layers emit. So you could let them communicate. Okay, so Kinetic.js requires a div. Oh yeah, so JS Fiddle, by the way, if you check it out and you go to libraries, Kinetic.js is right here. I'm actually going to pull in 444 because it's a newer version. It's a little bit faster. I need to contact them to ask them if they can update. Okay. So Kinetic.js. So the first thing you do, you need to create a stage. A stage is the viewport that houses everything that you see. Within the stage, you can create layers. So each layer has its own canvas element. And inside each layer, you can actually add an unlimited number of nested groups. So kind of like nesting div elements inside div elements inside div elements. And the leaf nodes of that tree are shapes. So there's all kinds of shapes that are provided out of the box. You can also create custom shapes, plugins, that sort of thing. So let's draw a simple circle. I just want to show you guys how clean the API is. I think it's pretty clean. So when I instantiate a stage, let's give it a width of 400 pixels, height of 300 pixels, and we have to tie the container element to it. So you can pass in the ID or a direct reference to the element. Does that look right? Okay, so you have a stage. The next thing you need to do is create a layer. In this case, I'll keep it simple. There's no configs for the layer. Let's create a circle. So circle. This is where it's really powerful because any shape can take up to like 50 or more config options. So it's really easy to configure the look and feel of a shape. So for this case, we'll put it at position 50. Give it a radius of 50, a fill color. Okay, so once you have your stage, your layer, and your circle, you need to put them together. So you need to basically say the layers inside the stage and the circles inside the layer. So let's do, and that's done with the add method. So layer.add circle and stage.add layer. This may or may not work, we'll see. Whew. Okay, so we have a circle. So let's do some cool things. The circle's pretty boring. Let's say we want to modify let's say we want to make it draggable. So Kinetic.js is the only library that makes this super easy. So all you have to do is add a draggable property to true, and it automatically handles, you got to run it first. It automatically handles making this drag and droppable on both desktop and mobile devices. So it does all the hard work for you. It takes into account all the different nested transforms that can occur when you're dragging and dropping something inside of containers. So all of that's done for you. Let's say we want to stretch it. You can just set the scale. Let's stretch it horizontally by like 2x. Okay, so now we have like an ellipse. Okay, let's add some event binders. This is the special part. Let's say we want to add a mouse over listener that changes the color of the oval now. So you can do circle.on, let's see, mouse over. So this is very similar to jQuery syntax. So on mouse over, we'll just say circle.setFill red. So with Kinetic.js, you can update as many attributes and properties as you want, and for performance reasons, you need to actually trigger the draw to re-render the scene. So after I've set the color to red, I can do layer.draw. I thought I'd turn this off. Okay, sorry guys. What's the question again? Flicker, what do you mean by flicker? There's no flicker. So the question was, is there a flicker if you're animating or doing lots of things? So I've spent a lot of time making the animations really sharp in Kinetic.js. There's a single animation engine. Everything that moves hooks into that engine. So there's one ticker. If there's multiple things moving, there's one ticker for the whole stage. Actually, not just the whole stage, all the stages, if you have multiple stages on the page. And what it does is it looks, and let's say we update the property of 5 different circles that are inside the same layer. That layer is not redrawn 5 times. It knows to batch all those together and do one redraw on that for each animation frame. So I've done a lot of work to make sure the animations are super, super fast. They're very, very, very clean. Okay, so mouse over. So we're going to set the fill to red, redraw. Let's see if this works. Cool. Okay, so also we need a mouse out, right? So we can change it back to green. Mouse out. Okay, mouse over, mouse out. Okay, I think we have about 10 minutes left, so I'll start wrapping up pretty soon. I'll add one more cool thing. Let's make it spin before I stop. So this is where it's really easy. So if you want to spin it, let's say circle, transition to. So with Kinetic.js, you can create custom animations, or you can use the transition to method, which will transition any node from one state to another state. So let's transition the rotation to math. So math.pi times 2 is 1 full rotation. We'll do 5 rotations. We'll do a duration of 3 seconds, Iron Man 3. And there's also 16 different types of easing. For this one, I'll do an easing of ease in out. So hopefully this spins. No, it doesn't. Let's see, rotation, duration, easing. Let's do some debugging real quick. What did I type in wrong? Transition to. Oh, thanks. Transition to. I was like, sure, it has a transition to method. I've been using this forever. Okay. Okay, spin. Cool, right? So it's a pretty clean API. It's extremely object-oriented, right? Okay, so time. I want to quickly run through some more items, and we'll call it a night. Let's see. Sure, quick question. So the question was, can you combine this with jQuery? The answer is actually yes and no. You can't use jQuery to modify Kinetic.js nodes because jQuery interacts with DOM elements, right? So if you have an application that uses Kinetic.js for the graphics, but maybe you might have some DOM elements layered on top, like some form controls or some other items that require DOM, you can use jQuery for that. But you can't use jQuery to access Kinetic.js nodes. So actually, Kinetic.js is almost like a browser. It manages a node tree for you, and it manages all the event delegation, or all the event propagation, capturing, and bubbling phases. But there's no way to access it outside of Kinetic.js. Yep. So the question was, can you use Kinetic.js for everything? The answer is yes, if you mean everything inside of the Canvas element. So all of the so a real website, no. The slot, like some of the examples that I showed earlier, it's a combination of Kinetic.js plus DOM. So you'll want to use Kinetic.js for any kind of graphical stuff. You'll want to use DOM elements for form elements, or maybe even like some text or some other kind of controls. Most people tend to kind of mix and match them together. Yep, question? Yep. Yes. Yeah, so the question is, for event handling, is there an event object? The answer is yes. I'm actually reusing the same, the actual DOM event object. So what happens under the covers, when you click on a circle, an event occurs on the container element. At that point, Kinetic.js intercepts that event and captures the event down the node tree to find the target shape. When it finds the target shape, it'll reuse that same event object and bubble it back up. It'll add one property, the target node property, which is used for event delegation. So since it's using the same, it's using the original DOM event object, you can like cancel event propagation by saying, you can cancel the event propagation similar to you can in a similar manner as you can with DOM elements. Sure. So is the question just how do I reduce flickering? There's actually never any flickering. I don't know what I can say of what I've done to reduce flickering. It's actually never had flickering from the beginning. So what happens under the covers, each animation loop, I clear certain pieces of the canvas, and the pieces that were updated get redrawn. So there's never a moment where you see a blank canvas. You would only see a flickering if it was like blank for a millisecond, but it always clears and redraws together. So you'll never see like any white behind the canvas. Any other questions so far?
So if you were to resize pages in Windows, does Kinetic pick up that event and...
So right now that's not automatic. It's really easy. You can just bind an event handler to listen for a DOM resize, and then you can set the stage width and height, and it'll automatically resize all of the canvas elements underneath.
And the elements you specified in pictures, can you specify them in canvas?
What was the question one more time?
So you specified like for instance, when you do the circle, you specified you specified one of the values in pixels.
Mm-hmm.
I'm wondering if you can specify it in the other units as well.
Oh, units. So Kinetic.js uses pixels only.
Okay.
No points or ems or anything like that. I kept it simple for now. If there's a demand for it by the community, I'll definitely think about adding that in. Sure. Absolutely. Kinetic.js is great for creating any kind of interactive charts. The question was, can you use Kinetic.js to create things similar to high charts? And the answer is yes. Yep. So the question is, can Kinetic.js handle layouts, I guess similar to like CSS, like floating or inline blocks to control a layout of the page? Not currently. It would be easy to write a plugin that kind of handles layouts, but not right now. I try to keep Kinetic.js as low level as possible because the intent is to have people build on top of it. So the question was, if you have 5 layers and you click on a layer which one gets the event, the one on top. So it uses, the event model is similar to the DOM. So the event object captures downwards until it finds the first shape on top. Once it hits that shape, that's the target node, and the event will bubble back upwards. Yes, and I don't know if I have time to show you guys some of those examples, but you have full control of, you can take a node, you can take it out of one container, move it to another container. You can change the ordering. There's a move up, move down, set z index, move to top, move to bottom. You have full control of the ordering. Okay, we're getting dangerously close to 1 hour, so I'm going to try to burn through. Any other questions real quick? Sure. It's actually really hard to hear. Would you mind, could we have the mic maybe switched back on? You're kind of far back there. Sorry.
How would you approach that?
The question was, if you want to click on a button, how would you talk to the backend?
Yeah.
Really easy. Just find a click listener to that button on click, and then make an AJAX call to communicate to your backend server. So it'd be the same principle as using like regular HTML. Sure.
Sorry.
Thanks.
In the live demo, when you drag the circle, are you able to find the new location?
Yes. So with Connect.js, as you drag, you have the option to hook into the new position. In fact, you can actually control the drag and drop, and you can override its next position. So it's really easy to constrain drag and drop vertically, horizontally. You can constrain it inside of shapes. There's lots of the options are limitless because you can control. It's called the drag bounds function. So you have complete control of how the drag and drop operates. Any other quick questions? Okay, I'll try to blow through this real quick because I know you guys probably want to get out of here. Let's see. Fortunately, the rest is pretty fast. I'm going to try to be quick. Okay, tell me more. Okay, I'm just going to read through this. So Connect.js supports an object-oriented API, node nesting, event bubbling, high-performance event detection via a color map hashing algorithm that I created. Layering support, node caching to improve draw performance. So any node, you can convert it to an image, which renders much faster than having to redraw the paths for each animation frame. Nodes, any node can be converted to data URLs, image data, or image objects. Connect.js is also the only library that allows you to serialize any node. So most of the other libraries give the ability to serialize an entire stage into JSON. Connect.js gives you the ability to serialize individual nodes. So like you can serialize a group that has 5 shapes nested inside of it, convert that to JSON and save it somewhere, and then you can reload that at a later time. It comes with built-in animation support, transition support, drag and drop, which is configurable with different constraints and bounds. Filters, so there's lots of filters to choose from, like blur, inverting colors, grayscale, masks. Ready-to-use shapes like rectangle, circles, images, text, lines, polygons, SVG paths, and more. Custom shapes, an event-driven architecture, which enables developers to subscribe to add or change events, like layer draw events and more. Selector support, which I mentioned, desktop and mobile events, AMD support. Pixel ratio optimizations, that's a really hard thing to deal with. So when you look, if you were to create a Canvas application natively without using a library, and you load that up on an iPhone, the iPhone will have a pixel ratio of 2, which will actually scale out the canvas and make images and text blurry. So Kinetic.js handles all of the pixel ratio stuff for you to keep text and images really sharp on both mobile and desktop applications. And also it has custom hit regions. So that's a pretty cool feature. So that circle that I showed you earlier, the default hit region is the circle itself. You can also create any kind of hit region. So you could put a rectangle around it, and when you mouse over that rectangular area, it can fire an event. So you have full control of the hit regions as well. I just want to quickly go through the events that are supported to let you guys know what's there. So everything you would hope is there. Mouse down, mouse up, mouse over, out, mouse enter, mouse leave, mouse move, click, double click, touch start, touch end, touch move, tap, double tap, grab start, or drag move, drag in, draw, before draw, add or change, and before add or change. So unit tests. So of course I have unit tests. I've actually written over 1,000 unit and functional tests. It's a very high quality project. Kinetic.js uses the TDD methodology, which is test-driven development. Every time I create a new feature or bug fix, it has a corresponding unit test or functional test with it. And to do this, I've actually also created my own testing framework specifically for Canvas, which has really helped a lot. CDN, I sure do. I'm hosting recent versions of Kinetic.js on Amazon CloudFront, which means that you can hot link to the CDN and get really fast response times anywhere in the world. Custom builds, definitely. So with Kinetic.js, there's a configurator page, which will allow you to pick and choose exactly which modules you want. And I can create, it enables you to create a custom build server side, so you can have just the exact functionality that you need to create the lowest file size. Naturally have documentation. I'm a stickler for it. So if you go to kineticjs.com and you click on documentation, you'll see the full JS doc pages. So yes, I've pretty much thought of everything. Okay, probably don't have time to go through this. So if you go to kineticjs.com, you can click on tutorials. There's a full suite of all the tutorials. It'll walk you through every major part of Kinetic.js. I personally think Kinetic.js has the best tutorials out there since it's really extensive. Tutorials are a first-class citizen for me, so as I build functionality, I keep the tutorials up to date, because if you don't have good tutorials, no one can figure out how to use the thing. Okay, that was a lot. Okay, so any other questions? Thanks.
Can you associate data with it? Like, for example, the DOM data set?
Yeah, similar to D3. Since Kinetic.js, the shapes are objects, you can create custom attributes. You can bind data to the objects.
Thank you.
Just two simple questions. So the first one is your presentation slides available after this?
Yes, so this is on the Google presentations, so we'll add a link to the meetup page afterwards.
The second question is, I saw the D3 has a lot of amazing stuff. So I know that from your first slides, you see there are different spaces. Can you do the similar things on D3 like those?
You absolutely can. So anything you can do in D3, you can do with Kinetic.js. So a quick thing about D3, before HTML5 Canvas, D3 was awesome. It supported SVG. It didn't support VML. So if you wanted to support older browsers, you would need to pair it with like GraphQL.js. But it was really easy to create data visualizations with D3. Problem is, it's very, very slow. If you want to plot like 100,000 nodes using D3, your browser is pretty much going to explode because you're going to have 100,000 DOM elements in your document. So it gets really slow if you add too many objects. Canvas can support that kind of scale with no problem. Any other questions? Sure.
Can you serialize the state of your item? Is it just like JSON data?
Yep, I'll show you real quick. The question was, if you want to serialize or deserialize, what does that look like? So kineticjs.com, this is the web page, by the way. All the links you could ever want are in this little gray band, so it's very centralized. Tutorials. And so serialization. So simple hexagon. To serialize it, you just say stage.toJSON. So you can do stage, layers, groups, nodes. You can do to JSON to anything. Once you have the JSON, which is actually very compact, by the way, I worked really hard to keep it as small as possible. Once you have the JSON and you want to load it, it looks like this. You do kinetic.node.create. It creates a node based on that JSON. So it's really easy to go back and forth. Any other questions? Am I off the hook? Okay, oh, one more. So the question is, does it handle zooming in? It absolutely can. So what you can do is, since everything in Kinetic.js is a node, including stage, layers, groups, and shapes, every node has the ability to scale. So what you could do is, you could actually, if you wanted to add a cool transition, zooming in and zooming out, you can scale the entire stage. And everything inside the stage can zoom in and out. So you can just do that with just regular JavaScript. If that makes sense. Sure, one more question.
Can you handle streaming? So like suppose the data is streaming. Can you handle streaming? So the data is streaming as you draw in the graph.
Sure,
the data
you
keep
absolutely
coming
can.
in.
That's more of an implementation issue. So if you want to be able to draw data dynamically, as the data is coming in, you can create Kinetic.js objects on the fly and add them to the stage as the data comes in. So you could absolutely do that.
Thank you.
Any other questions? No? Oh, one more. Okay.
Really fast. The graphics are all like really fast. Is there like double buffering or something that you're doing or HTML5 is doing or what?
So it's fast because I've done a lot of crazy stuff to make it fast. The animation, seriously, the animation engine has all kinds of optimizations. The event detection is it uses a color hashing algorithm that I created to make it super fast. The animations get faster and faster with each release. It really does. The rendering does get faster with each release. So it's super fast now. I plan to continue making it faster.
So you have a rendering engine per stage?
No, there's one, the question, I guess you heard, there's one animation engine for everything. So there's a global, there's kind of a global object that's not exposed to the developer, and it manages all the canvases, all the stages together. So if you had like 10 different stages, for example, and you have multiple animations, drag and drop, transitions, sprites, I also support sprites if you're creating games. All of that stuff hooks into one animation engine, and things get updated on each tick. Yeah, it's my tutorials website. So let's do, so this is, I'm pretty sure, I think this is either #1 or #2 tutorials website out there. It gets about 750,000 page views per month. So that's pretty popular. Let's go to a rectangle tutorial. So I'm using Code Mirror for the code, which means you can edit the code directly and see the result. So right now I'm drawing a green rectangle. Let's say I want to change it to red. It's red. So you can update the code to play with different config options. Any other questions? Okay, I'm finally off the hook, and I'll let Seth come back up here. Thank you, guys.